Hello, students. I just wanted to give you a very last minute run through the redox reactions because I saw in my office hours many students had questions about it. So let me just go through it very quickly. Uh, so, wait a minute. Okay, so in the reaction number one, we're dealing with copper, solid copper plus uh, nitric acid. And nitric acid is aqueous, and you produce copper nitrate, which is also aqueous, and also produce nitrogen dioxide gas and water, which is a liquid. And if we go to if we write the total ionic equation of this reaction, we get that we have copper plus ions plus nitrates, which have a negative charge. And on the other side, you have copper with +2 charge, plus 2 nitrate ions, plus, oh, sorry for this, it's only one, 2 gas, and NO2, N2O gas, and water. And here, you can see, first of all, we need to write down the oxidation states of the atoms inside each of these ions. So for example, the nitrate ion, which is NO3, and let's write down its charge like this. The oxygen in this ion has a charge of -2, and the total charge is -1. So the charge of oxygen, which is -2, times the number of oxygen atoms, plus the charge of the nitrogen, plus times the number of nitrogens. Let me just write a line right here. This. If we solve for this equation, we get that the charge of nitrogen is actually, this is -6, so you get +5. So we write down that like this, and let's see if that makes sense. So -2 times 3 is -6, +5 should give you -1, which is the formal charge of the ion. If we do the same for the nitrogen dioxide molecule, nitrogen dioxide is, it has a charge of 0, and that means that all the added charges should be equal to 0. For oxygen is 2-, same as before, times 2 oxygens, and only one atom of nitrogen. So that charge of nitrogen can be solved from this equation. And this gives us that the nitrogen in this compound is equal to +4. That means that the nitrogen has a charge of 4+ in this compound, oxygen -2. Here is a 4+ -2. It should give you a total of 0. And we can see that the nitrogen in this ion goes from a charge of 5+ to a charge of 4+. Or in another way of saying it, it's changing its oxidation state from 5 plus to 4 plus. On the other hand, copper, which is 0, goes from 0 to 2 plus. So copper is losing electrons. We can write down the half equation for that as copper goes to copper 2 plus the number of electrons which it's losing. So it's only 2 electrons. And as it's losing electrons, this is an oxidation. We can write the rest of the reactants and products for the other half reaction. So it would be protons plus nitrate ions. And they produce nitrates. But in this case, nitrates are expectating because the limiting reagent is copper. Therefore, you will still have unreacted nitrates in solution. So let's not include the nitrate, just the nitrogen dioxide. So it's nitrogen dioxide plus water. And if you take a look at the oxidation states, remember here is nitrogen is 5 plus, oxygen is 2 plus, which gives us a total of -1. And in here it was 4 plus, and 2 minus, which gives us a total of 0. For water, it's 2 minus for the oxygen, and plus for the hydrogen, which is plus times 2 is 2 plus 2 minus, it's equal to 0, so it's neutral. This means that the nitrogen is, okay. Okay. This means that the nitrogen is it's actually gaining electrons. So we should include those electrons in the half reaction as an electron. Goes to nitrogen dioxide plus H2O. And now we can start to balance the mass. So you can see here that in the reactants we have 1 nitrogen, and in the products we have 1 nitrogen, so that's balanced. In the oxygen we have oxygens in the reactants we have 3. The products we also have 3, 2 here and 1 here. But hydrogens in the reactants we have 1, and in the products we have 2 hydrogens, so there should be 2 hydrogens here. And now it's balanced, mass balanced. And if we, this is actually the reduction reaction. So if we remember from here, right here, this is the oxidation, and this is a reduction. Remember to include your oxidation states or your charges in the nitrogens for the half reaction. And another important thing is charge neutrality. So if 2 electrons are being lost in the oxidation, 2 should be gained in the reduction. This means that this reaction is incomplete. 2 of these reactions have to occur for one of the oxidation. 2 reductions for 1 oxidation, meaning that you must multiply this by 2. And this gives us 4 protons plus 2 nitrate ions plus 2 electrons equals to 2 NO2 gas plus 2 water molecules. And this is a complete reduction reaction. Now we can couple this together, couple this together to write down the total equation. Let me just maybe so. It would be copper, solid copper plus 4 protons plus 2 nitrates plus 2 electrons equal, now the products, which are these 2 copper ions plus 2 electrons, and the products on this one, 2 NO2 plus 2 water molecules. And now we can cancel out the electrons, this one and this one. And as you can see here, we are missing charges because here we have 4 positive and we have 2 negative, and here we have only 2 positive. Therefore, we need nitrates to complete the charge balance. So it will require from this side two other nitrates, and in this side 2 other nitrates. This way everything is balanced out, and we finish with the complete balanced equation, which is 4. These 2 are parts of the nitric acid. Actually, so it's 2 plus 2, which is 4. This one, coupled with these ones, and this is aqueous. And on the other side, we get copper sulfate, which is also aqueous, plus 2 molecules of nitrogen dioxide gas, plus 2 water molecules. And this is the overall equation, balanced overall equation for the redox reaction number 1. And we can also take a look at the 5th reaction. So the 5th reaction is actually easier because we don't have to do that much work on the balancing. So this is the reaction. And 6. Like this. This is aqueous. And here we can see, if you remember, we were sacrificing aluminum to produce copper. And the oxidation state from copper went from 2 to 0. So it was a reduction. And the aluminum went from 0 to whatever charge we have in this other compound. So this is the oxidation, and this is the reduction. If we separate out the equation into the ions, so the ionic equation, total ionic, we can see that 3 copper ions plus 3 sulfate ions. In this case, sulfate has a charge of 2 ions, plus aluminum, oxidation state of 0, and we have 3 copper atoms, plus in here, if you remember, the sulfates have a charge of 2 minus. So if this compound is neutral, this means that aluminum must have a 3 plus charge to balance out this. And if we write it down, it's like 2 minus charge of the sulfates times 3 sulfates plus 3 plus the charge of the aluminum times the number of aluminum atoms, and this gives us 0, which is a total charge. So that's why aluminum has a 3 plus charge. And it's 2 3 plus 3 sulfate ions. And you can see these ones are expectating ions. Therefore, we can just write down the half equations, the reduction and oxidation for these two processes. Let's go first for the reduction. So copper 2 plus has to gain 2 electrons to form 1 atom of metallic copper. And aluminum has to lose 3 electrons to go to a +3 charge or oxidation state, like so. And you can see that the charge is not balanced, because here you have to gain 2 electrons, and here you have to lose 3 electrons. So in order to balance out the charges for the electrons, we need to multiply this one times 3 and this one times 2. And if we do so, we get the number of total electrons, which is 6. And aluminum is 2. Aluminum 0 goes to 2 aluminum 3 plus 6 electrons. And we can now add everything up. So we will have 2 aluminum atoms plus 3 copper ions plus 6 electrons go to form 3 copper atoms plus 2 aluminum ions plus 6 electrons, and electrons cancel out. We also need counter ions, because if you remember, the sulfates were expectating ions, so we can include them here. In this case, copper has a charge of 2 plus, so we need 3 of these ones to cancel out the charges. And here aluminum has a charge of +3, therefore we need also 3 to cancel out the charges. And therefore the complete balance equation is, this one is solid. This is 3 copper sulfates aqueous, and you recover 3 atoms copper plus 1 aluminum sulfate, which is aqueous. And this is the overall balanced equation for the reaction number 5. And that's it.